Hi, Alvaro. I hope pronounced perfectly right now after practicing a lot.
Good memory. Yes, you did. Hello, Adam.
Hi. How is your new computer, the framework, doing? Because we met last time in Seattle and you told me you ordered the framework. So I'm really curious because this is something new, right?
Yep, that is correct. So I'm loving it so far.
hmm
First of
What is
all,
it first? So,
okay,
explain. Yeah.
yeah, that's a good one. So framework is this idea. I mean, have you built? I guess so, but how many of you actually extending the question to the audience? Have you built computers by yourself? I love hardware. It's pretty much anything else in computing, and I've built I don't know dozens of computers. But laptops? Do you build laptops? Not so much, right? I mean, sometimes I've tinkered with a little bit with some laptops to fix something, but they're not easy to fix. They're not easy to work with. So framework is a laptop that is designed for replaceability, for upgradability, for fixability, right? I don't know if I came up with some of those terms, but you get the point, right? You can actually tinker and build your laptop so much that the edition that I bought is called Do It Yourself, and it's sold in parts.
hmm
So actually, I got it in Seattle, in the United States, when I was there, and I picked it. Yeah, came a box with a lot of parts, and scan some QR code, get a video, see how to build it. I built it with my son, and it was a great experience. Actually, to be honest, it's pretty much built. So it didn't took us too long. It was like 20, 30 minutes, just
hmm
carefully building everything. It was a very smooth experience. Now, the cool part about the framework is that you can upgrade almost anything. For example, even the motherboard. Like, oh, you keep the screen, you replace the motherboard. You can switch the processor, right? And any other component, and has even a marketplace so that third-party providers are creating accessories for the framework. But one of the things that is very cool is the connectors. Almost every other laptop has the connectors that are built in. So two
hmm
USB-Cs, one USB-A, one HDMI, whatever. The framework has just 4 bays, and you plug in and swap out modules. And these modules can be anything. It could be USB-C, USB-A, Ethernet, whatever. So I have 4 bays. I purchased 6 modules, and I can swap them in and out as I please. So anytime I want, I have the connectors that I want. It's really cool. Now, this is for the hardware part. Software part, they're totally designed for Linux. No question what I'm running. And so I'm starting the journey
What are
to.
you running? Which Linux distribution are you running?
So this is going to be subject of a future topic, blog post that I will write, because my goal is to fully automate my installation so that I can always reproduce it and bring it to the laptop. And if one day my laptop dies, I get another one, and in 30 minutes I should be back and running again. So I'm running Ubuntu as a pretty recent version, 25.10. It's not out yet, so I'm running the beta version. It's because it's a modern CPU. I've got one of the most powerful Ryzen AI CPUs with integrated memory, 128 gigabytes. So it's impressive hardware. Yes, I'm planning to run local LLMs on it, and so I need a recent kernel. So I picked Ubuntu 25.10 beta version. But most interestingly, I wanted to make my laptop, again, easily reproducible. So I'm running almost all the user land on Nix. So it's basically Ubuntu layer or Ubuntu base, and on top of that, Nix, the package manager. And so I'm automating the install first Ubuntu with something called auto-install.yaml. So you can generate a YAML, and at the very early stages of installation, you import it via HTTP, and boom, everything gets installed in takes like 5 or 6 minutes to install. Reboots automatically, you're done. Then a
I
bit
have to mention to the audience that your actual job, you are CEO of a company, right?
yeah, apparently.
Yeah, this is perfect actually. So so this is amazing. So yeah, and what about Omarshi? You heard about that?
Sorry, say it again.
Omarshi.
Oh yeah, yeah. I've definitely looked into it. Looks very interesting to me. But I'm a quite easily, quite easygoing person. Just basic GNOME desktop. I'm good with
Yeah.
that.
hmm
Looks very good. I'll maybe devote some time to experience around it. But I'm more caring about availability of software and packages. So I
Yeah.
want the Ubuntu base because it's solid. It's a good
hmm
UI. And
hmm
and even if you need some commercial application, sometimes Zoom, for example, comes to mind, even though I barely use it anymore. But you can install it easily. There's a package for Ubuntu, some drivers, printers,
Oh
whatever.
yeah. Okay.
But then I
hmm
want the user land with Nix because I'm starting to experiment with Nix and I like the idea very much. So I'm automating the whole software installation. First Ubuntu auto install, then a bit of Ansible to wire things up and install Nix, and then Nix installation with Home Manager. So yeah, I'll blog about it in the future, but that's my current steps and what I do.
This reminds me about how I introduced Docker, because I maintain my own server, and every 3 years I replace the hardware just for fun. So I just buy the and I assemble from parts. And for me, the most important thing was and is energy consumption, and then it's not more that easy, because you need specific chip. I remember I bought back then this Intel, and there were Intel chips which were more energy efficient. So this years ago, and for that you need special board, and the board is compatible with RAM. So I worked backwards from the chip board, and if you have board, I wanted to have SSDs and stuff like that. But every 3 years, so it was really hard to document what I did back then, because you need the firewall rules, and I always forgot what I actually did. So, and this was the reason why I introduced Docker, because the next idea is there will be nothing on the server, just the Docker, and everything else is in Docker. So I had all the software which matter in Docker, and then what happened is I could actually develop my laptop and push to my server. So all the major parts, like my blog, for instance, and all the things run in Docker. And then Docker blew up. That I started with version 0.3 or very, very, very early, because actually I wanted to use Open Solaris with the jails.
Yep.
Open Solaris, yeah, with jails. But then it was 2010, and it seems like Oracle didn't like Open Solaris. So I said, okay, I need alternatives. And then the only alternative I found back then was the Docker, but this was the very early version, which with corrupted file system and stuff like that. Yeah. But I ran back then, Glassfish, Whitefly, whatever. And then I heard on the internet, Java is not Dockerized. I was like, what are you talking about? I'm running this for 2 years. And then I submitted some talks, and then they become really popular. But this was actually the story. I never wanted, my motivation to use Docker was to have nice backups. And the Docker file was clearly documented what I did, because it says do this, do this, do this, do this. And this was actually, and this is actually worked out. And now I'm thinking to removing the Docker from my server, because with Quarkus, I could just ship one jar, and this was similar experience. So just to do something different. I'm perfectly happy with Docker, but maybe bare metal experience would be nice. So this was my and the Nix is what you're doing right now is similar on the notebook part, just to automate everything, which is great. So and the frame you can have as power. So what I like about the concept, you can upgrade to the extreme. This is what I like. You could buy, the recent CPU or more memory. This is what I like about that. This is what I do on the server. I have a nice chassis. This is looks beautiful. And this I have it, I think, for 10 years, and it's still, a huge tower. And then I can replace whatever I like, and this is what I enjoy, because it is easy to enjoy. And I think I could also assemble the server if I have the parts in half an hour. So I have the a power supply was a big deal back then. I wanted to have platinum ones with high efficiency, 90% or more. So this was lots of fun. Yeah.
Yes. It's a very enjoyable experience.
Yeah, I think if I will need an Linux laptop to do something different, I also will buy framework. And what reminds me as well about ThinkPad. So my IBM ThinkPad 31P. It was partially modular, because I could replace CD-ROM drive with battery, for instance.
Yeah.
So there were modules, for the CD-ROM. So this was also cool, because sometimes if I was on the road, it's okay, I would need more battery. So I plugged the battery to CD-ROM and left the CD-ROM drive at home. So and yeah. So pretty cool.
Way, let me add something, because I'm right now transitioning from my old laptop to the new laptop. The old laptop is a ThinkPad X1 Carbon, also fantastic laptop that I really enjoyed very much. But it's kind of 5 or 6 years old already, and I was happy with it. And when I started using the framework, which is latest CPU, it's top of the line, right? The Ryzen 395. It's like, oh my God, this is so much faster. I mean, the difference is stunning. And I've been using a lot LXC containers, actually, just to try like a quick VM for quick testing the installation itself. So I create a VM and run Ansible against it, so I can test things faster. And it's like a difference between taking 10-15 seconds to 1-2 seconds starting a VM. I mean, an LXC container. It looks like a VM, right? And it's really stunning the amount of productivity you can gain by actually having modern hardware. So I'm really impressed. I'm very happy with the experience so far. X1 Carbon also love it. No worries. But this framework is I mean, I could even pick my keyboard. And so I'll select the type of keyboard I want. And if I'm not happy with this, okay, I'll replace it. It just costs 40 or whatever, $20, right? And you replace it straight swap for another one. So it's very cool.
Yeah, this is what I like. It's not about, it is also about quality. And what is the build quality? Is it great? So if you compare it, for instance, to Mac or to the ThinkPad, so how it is? Can it be improved?
It's not the same build quality as you can get from top brands. But to me, I was experiencing less build quality. It feels very, very solid for me. I mean, I will see in a couple of years. But so far,
I'm not about the solidity, but because after 2 years I have to replace it anyway because I use it that much that the chances that it breaks are very high. So I try not to replace my work machine every 2 years or something like this, because it's not worth the SSDs, whatever, the entire components are overheating, whatever. And what about the niceness? If you look at this and the screen. This is very good because how solid it is for me less important because it's work machine and I have to replace it anyway. So
also, it doesn't matter much because it's replaceable. If something breaks, we'll just change it.
Yeah, but if it breaks on the road, this is imagine for us, if I
always take 2 laptops with me.
Okay, this is what I also did. This is what I did a lot back then, but now I enjoy one, but it's a little bit dangerous. Yeah. You're right. Yeah, if you have 2 frames, it's actually cool because if one breaks, you can swap the part and go, right?
Okay, yeah, that's a good one. Yeah.
This is actually because you could have 2 frames, and the other one is not fully operational because you can swap SSDs or whatever. You know what I mean? So if one breaks, you can have some spare parts and you can create. This is actually a perfect because what my situation right now is, I have a work machine and the older machine, which are somehow compatible. And I do a backup. If one breaks, I can in 2 hours be operational with the other one. But with frames, it's even to the next level.
Yep.
Because if motherboard breaks, I could just swap the drive and I'm immediately operational.
Yep. Exactly. Yeah.
Hey, super cool.
Indeed.
Super cool. One interesting thing, maybe for you, because I had a nice conversation in the last podcast with software about Job Runner, and I immediately thought about you. Maybe it is also interesting for your database cloud. It was with Ronald. It's an open source Java project. 3K stars on GitHub.
Nice.
0 dependencies. Used by large companies as a startup. 5 years. And what he did is a job scheduler with Java, pure Java, which you can schedule jobs and you can serialize the jobs that they are persistent. So you can run them. And what Ronald also implemented is that you can run the jobs if the energy is cheap, which are CO2 efficient. Nice. But he stores the data to MongoDB and it runs on Kubernetes or whatever. So I thought about you. It's like, this would be actually cool because you have a scheduler job, you can run this on your Kubernetes cloud. And then I convinced him to look at Lambda and S3. Because I said, why are you running Mongo? You could store the state in S3 and whatever. And he said, yeah, this is actually a good idea. And he will look at this. And he's also our mindset, right? No dependencies, recent Java. And he's successful. And it's open source. So, and I'm just saying, you can listen to the podcast, but maybe if you have no recurring jobs or whatever, I think they will be super fit. So that you can have, job scheduling plus your stuff. And yeah, think about this because this is interesting stuff. This open source can look, and I just found interesting because it's a similar mindset. Both of you.
Absolutely. And actually, there's in this vein, there's similar software that might be interesting also for this project, which is called IBM AS. I don't know if you have checked it out, but it's basically a layer on top of Postgres. Yeah, I'm coming back to my topic, Postgres, of course, but it's a layer on top of Postgres designed for, it's designed for many things, but it's one of the use cases or best use cases is actually persistence for workflows, so that it applies transactionality, so that any state of any part of a moving workflow, you can persist it and always warranty that the state is consistent with your business rules. And so much you can even technically even replay a given running of something because it persists all the state, all the inputs, all the outputs. And so it's a nice layer. It's a much deeper concept, what they're trying to do at DBOS. But it's very interesting and it's very related as of now, current use case with workflows.
Super cool. But also take a look at Job Runner is the name of the software.
Yep.
jobrunner.io, and can listen to the podcast, the last one.
And
yeah. And I know the guy for longer, but I as we explain, the how it works and failover and how it works behind the scenes, I immediately thought about your database cloud, the on-grass, and yeah.
Yeah.
But today's topic are dynamic containers, right? So this is what we actually committed to do. So this is for outstanding for 1 year. Yeah.
Yeah, indeed.
So, and you had a crazy concept to create containers on the fly, right? This is what I understood.
Yeah. That is the
Why are you doing this? How you got the idea, what it is, and maybe explain it briefly. And yeah.
Yeah. So let me start with the problem we were facing at my company, right? So we are building. My company is called OnGres, which means on Postgres, right? So everything we do is Postgres. So we're building things for Postgres, and we're building container images for Postgres because we run Postgres containerized in Kubernetes mostly, but not only. And so one of the problems that we faced is how to deal with extensions. Just for the audience, if you're not familiar with Postgres, what are extensions? Postgres extensions are pretty much like plugins for the browser. It's a piece of code that you can add to your Postgres, like a plugin to your browser, which enhances the browser or Postgres in a given way. Right? It could be as simple as adding an extra user-defined function, but could be as advanced as adding new data types, operators, changing the Postgres planner, changing the Postgres query executor. They can go very deep, adding new indexes, that index types, right? That is also permitted as Postgres extensions. So they can go from the very simple to the really advanced ones. And the really advanced ones, there's this extension called Timescale that transforms Postgres into an IoT time series database, right? There's Citus, which actually transforms Postgres into a distributed sharded database with multiple nodes. Right?
Alvaro, this timescale, they had, I remember, problematic license, right? It became commercial. You couldn't, the timescale, is the open source alternative or something? Because...
Yeah, so Timescale has 2 licenses.
Mm-hmm.
It has a Apache 2 base license, and then they're all on the same repo. And then you can build either this Apache 2 license, and then there is a version with more advanced functionality, and there are, technically proprietary license called the Timescale license, which adds some interesting bits, honestly, to time series functionality on Postgres. Not being fully open source, it is a source available license, so you can still see the source code on GitHub. And there are, I would say, small restrictions on running that, but it's not purely open source.
Because why I'm asking is because I had some clients and they used that, and we look at this, and this was not clear whether we still can use it or not. This was for us okay. It's really hard to tell because they build products, and this timescale was used, and this was okay. I'm not a lawyer, so this always a little bit problematic. It's not like for me, I would just go. I wouldn't care. I would go with open source, but if you use it commercially, it's always the question, I cannot tell you whether we can use it or not. We have to ask a lawyer, and then it usually dies. This is the problem.
Yeah, well, I'm definitely here not a speaker for Timescale. But in my understanding, and even though I'm a strong OSS supporter, the license basically allows for any kind of usage unless you're a hyperscaler. Put it that way, right? Actually, because we run our software StackRest, which is open source software for running Postgres on Kubernetes, and it allows a lot of extensions. We support both extensions, so users are free to pick either, depending on their concerns or about open source software or licensing or not. And I can tell you that looking at the numbers, both get huge usage. I don't know exactly which one is used above the other one, but both are widely used and very, very popular.
But my clients back then, it was a kind of a cloud. And I say, okay, what means hyperscaler? This is a problem. This is if you, let's say we can consider OnGres, and if you hit a size, I can say, okay, now you're a hyperscaler and you have 200 clients, because this is loosely defined terms. So that's the problem, which I don't like, because if the client grow, then could be, there's always the problem. Or, remember there was React in the early days was similar. They say, okay, you can use it if you are not competing with what doesn't mean, this is always problematic because
it's not clearly defined.
Okay, cool.
I would recommend talking to them. That's what I did, actually.
This is what I also recommended. Okay, great. Sorry for interrupting you again, but always,
That's what makes your podcast really interesting. That is all naturally flowing and switching.
Okay, so the extensions, back to track extensions. Sorry, now.
Exactly. So Postgres allows, these extensions that enhance the database functionality. There's a lot of extensions, and there's like a total of around 1,000 extensions. And people tend to use extensions a lot. It's very unusual to see Postgres with 0 extensions. Normally there's 1, 2, 3, 5, 10 extensions. out of the wider set, and the long tail is very long. Like there's users who use extensions that others not use that much, but all subsets are different. So now let's think about how we can create a Postgres image that allows users to run extensions. Naive approach would be fine. I'm not going to pack 1,000 extensions. Those are, by the way, these extensions are, most of them are found on GitHub on random repositories, and the quality varies a lot. They're like really, really, good extensions, solid and safe, while others are just experiments that people build on a weekend and they maybe not updated from a security perspective, or they may crash your server, because they could do that technically, right? So, but we want to use our users the ability to run whatever they consider. And if it, crashes your server, that's up to you, but we want to give you this freedom because it's part of our core tenets. So anyway, we're thinking, how do we pack a container with Postgres and the extensions? And there are several options. The most naive approach is, okay, I want to give our users a big subset of the extensions. For example, we packed around now 200 extensions. So, okay, we'll build a container with Postgres plus these 200 extensions, which come from 200 GitHub repositories, right? Well, if we do this, what we're creating is a pretty large image. Postgres is actually quite small. The official Docker image, which by the way is official for Docker, not official for Postgres, but most people take it as a reference, is around 400 to 600 megabytes depending on the version. Actually, we've done Docker containers less than 100 megabytes, but this is the ballpark. If we take these 200 extensions, it will be 4 gigabytes. Do you want to create a 4 gigabytes image for users who mostly will you pick 1 or 2 extensions or 3? Like maybe this is not the best idea. But what about security? Containers should be minimal and targeting strictly only the files that you're going to be using and the programs you're going to be using. So now here we're packing 200 extensions. When you, Adam, you will pick these 3, another user will pick another 3, and another user will pick another 5. So this is a bad approach, and from a security perspective, it's terrible. People don't
security perspective is the problem, because what I did in the past, we built a product, Java, and we did exactly that. So we shipped larger image, but not everything was active. And the cool story is we only had one product. There was no variations, one CI/CD pipeline, and with the toggles we can switch on and off the things. And I got the idea from AS400. I was, from Monolith's host system, legacy system, huge machine. And I was in a project, and they were supposed to upgrade the hardware. And I was really curious because I also assembled servers. I was like, can I just, watch this? Because it was one of the largest AS400 server. So yeah, cool, go here. And the IBM guy came in and he said, it's done. He didn't even open the server. I said, okay, this is a little boring. What you did? I was like, I just activated the feature. So it means the machine was shipped fully loaded.
Yep.
And what he did, he just, activated the more CPUs or whatever he did memory long time ago. And I say, this is actually a cool idea. It is cheaper to ship everything because they only have one build for all clients and then pay, if you would like to have more. But from security perspective, this is terrible because you have to take ownership of all extensions. But if the security were perfect, I would consider actually to ship the 4 gig image, because 4 gig is not much. I mean, really not. Nowadays, this is like a iPhone image, maybe, right? So a picture, iPhone picture, maybe. And but interesting. There are two opposite approaches which both are working, but in your case, security is the problem. And of course, upgradability. Because to upgrade one, you will have to reship all the things, right?
Yeah. Exactly. Very good point. Upgradability is the second biggest problem. Actually, size matters here, but in a very indirect way. I mean, in general, networks are as fast, storage is fast, and whatever, right? But when you want to restart a database, so databases are software pieces that can take very little downtime. If your database is a primary node, you basically don't want it down ever, right? So if you have a large container image, it will take seconds to restart. And those are pieces of seconds that you don't want to be down offline, right? So it also matters. But yes, upgradability is a huge problem. Well,
how much does it matter? So the 4 gigs really, because I'm really interested in, because, for instance, Lambda, I do lots of serverless and Quarkus and Lambda, right? And it doesn't matter that much if I just use my classes. Of course, if my Lambda image becomes huge, then it matters one point of time. But from the business perspective, I can write hundreds of classes. So there's no difference. So there's actually, but if I will add, I don't know, lots of jars, external jars, there is a difference. But I think the difference is more on the Java side, not network side. So how it is different? You had some experience, if you would have full image with 4 gig on 100 megs, what would be the difference in startup time?
So let me give you 2 examples. One, because the difference is that here we're talking about stateful software, right? It has state, has persistence, and with the stateless software, it's totally different. Yes, it barely doesn't matter because you can run concurrently, you can scale out, you can do all those things. But Postgres is a storage software, right? It's a database that follows a primary replicas architecture, which means there's only one writable node. That's it. You can scale it. There's one. So if this node needs to restart, and upon restart, you're going to download a new image because you're just updating it to a new version, right? The startup time, it's going to be your downtime. And databases normally, they want 0 downtime, right? So if it takes...
I get you. But what is the difference?
It's much worse than 3 seconds.
Okay, but you have concrete example. You did some math, or you saw this 4 gigabytes versus 100 megs on your network or AWS network?
Yeah. And it's a difference of seconds because it's not only download time, it's download, unpacking, building, the process of building the layers in your file system called the
Okay, but this is like 1 second and 10 seconds, something like this, right? So this is the ballpark. Okay, super cool, because I did lots of CI/CD pipelines on AWS, and I downloaded...
Yes, sorry to interrupt you, but you just mentioned the second use case, CI/CD pipelines.
Yeah.
For people who use CI/CD pipelines that run databases like Postgres as part of the CI/CD pipeline, for example, you're running your application that uses Postgres, and you're doing a lot of testing as part of your pipeline, right?
Yeah.
Sometimes you're instantiating Postgres database servers hundreds of times, for example, with test containers. And their startup time of the container matters a lot. And by switching to a much smaller image, you can run your pipeline so much faster. And actually, this is why we're also targeting like really, really tiny Postgres container images. This is a bit on the experimental side, but we're targeting less than 40 megabytes.
Why I'm stressing this point is because in my project, I'm mostly, Java projects, and they are obsessed with the size, and they use strange minimalistic operating system who no one saw, just to have a better startup time. And I asked them, and what I did once, I just picked the Red Hat Enterprise Linux as a base image, and then Whitefly, and it was almost no difference. There may be a difference, like, as you say, 2-3 seconds. It's like, you're fiddling 2 weeks. I did nothing, and we are almost as fast. So, but this is completely different use case in your case. But what I just wanted to say is, I implemented CI/CD pipeline, and I think I had to download Java or something. Java is already there as a runtime, but I downloaded 100 megs of something, and I think it doesn't work. This was the copy command in code pipeline, code build, and it was like half a second or once. It's like what's going on here? And the network inside the cloud is incredibly fast. So this is what I wanted to see. This is unbelievable. And I say, okay, it doesn't work. Why not? And I say, okay, it works. It's just incredibly fast. But in your case, okay, the Docker is one thing, this download, but it has to be extracted. It has to be understood, parsed, and okay. But good to know. So the order of magnitude is like 10 times, but it's instead of 1, 2 seconds, 20 seconds or 10 seconds or something like this. But it still matters a lot because in 10 seconds we can have thousands of transactions, right, which are waiting or queued. So this is for you, it's just very reasonable. For my for my enterprise projects, not everyone will use dynamic containers to make Quarkus start 10 milliseconds faster. So this is what is warning.
And stateless applications, it doesn't matter start at time of one because you can have many others in parallel. Yeah. But in Postgres, you have a primary, and there's only one primary. Yeah. Replicas, yes, maybe you can fiddle with them because you have multiple, but the writable node is only one. So you want to keep it, down close to 0.
Cool. So, okay. And this was your problem statement. So you wanted to separate the extensions from the Postgres base image, right?
Exactly. So approach 1, build everything into the container. We already agreed is a bad practice. Security, the most important one, size, and upgradability. So for our project for Stagres, which is, again, the platform, the open source platform that we have built to run Postgres on Kubernetes, we had to face this problem, right? So what we did is create container images with 0 extensions. And then we developed, by the way, Stagres is fully built in Java, as you know, right? So we developed a sidecar that we call the pod local controller that just runs alongside Postgres. And basically what it does is that when the user says, oh, add me to my cluster this particular extension, timescale or whatever, it will go to a repository, fetch the code for the extension, validate the digital signature, and deploy it to the primary node and all the replicas across the cluster locally on top of the file system. So in other words, it dynamically injects the code into the container.
But is it the last layer or the first one?
Actually, it builds it on top of the last layer, the top layer. Then we actually do a process called relocation, where we relocate to the volume where the database resides. So we co-locate with the data, let's say, so that it persists, restarts, and we don't need to repeat this operation more than needed.
Because if you do nothing with Docker, the base image is on top, and then let's say you get Quarkus to be the next one, and then whatever. So this is like you are adding, and everything is immutable, right? So it's consistent hashing. So we have one. And
this is the main problem with this approach, that from a technical perspective, this works and works quite well. But the problem is that some security tools, especially on Kubernetes land, where there's a lot of policies and standards, right, that you can automate, they will flag immediately this because they're saying, oh, you're modifying the running image. Even though we're not really modifying the image, but we're writing on top of it. And this is also like a security potential risk, according to some policies, not for everybody, but it's also not ideal. So we're modifying the running image. One of the principles of containers is that they're immutable. We're hacking here a little bit the system to make them mutable. And so the image you analyze from a security perspective when you start a cluster is not the same one you're effectively having at runtime.
So what is different in your case? What I will see the difference?
Adding extensions. So we're adding these bits of code that we're downloading at runtime, and so the effective image is not the same one that we started. I mean,
so you change the hash ID is changed, or how it's called the Docker? How it's called the ID? No, the layer ID is changed, or you get new layer.
It's not a new layer. We cannot modify the running snapshot of typically the overlay file system, right? We cannot modify that. It's not allowed on Kubernetes. Once you start an image, the image cannot be changed. But you can modify the OS, let's say, perspective that we're running on top of it. So if you take a snapshot of the OS before running the container and after running the container and adding an extension, you'll find code differences. And this is what some security tools will flag as a non-ideal. And I agree, it's not ideal. It's not terribly bad. I mean, the user is making a conscious decision of bringing some extensions into the container runtime, but still, we want to comply with these tools and as much as possible stick to this immutability principle of your container image so that you can analyze it statically before running anything and then run whatever you consider, right? So that's where we do a lot of R&D. We try to come up with solutions to the problems that we find. And we're thinking, how can we have container? I mean, the dream is I want to have a container with exactly what I want. You want these 3 extensions? Okay, I want a container with these 3 extensions. You want a container with 7 extensions? Okay, a container with 7 extensions. So actually, there's something you can more or less easily do with Docker, right? You take the Docker file of the base image, then you derive from it, then you download the extensions that you want, you build a container tool, you bring the compiling tools, and you build it, and probably, of course, you do this multi-layer, multi-state, so that you don't bring in all the compiler stuff on the final image, and then you build the image, and you're done. Except that this process is quite involved. It requires expertise. Not everybody knows how to build an extension. You can very easily do it wrong and left stuff on the final image that you don't need. And now you have become a maintainer of your image. Now, if there's an update or a security problem, now you are responsible for rebuilding it, redistributing it, validating security. And this is putting a lot of burden onto users. So
you're right. This is just to recap, because what I will have to do is I will have to download the official Postgres image or create my own Docker file with from official Postgres, and then I'm adding my extensions. And this has to be built and pushed somewhere. So you have the first problem in CI/CD pipeline, for instance. I will need another stage, and the first stage will create the image first, which could be used by all other pipelines. This would be the real problem. in my projects because and not of course tell all developers don't use the Postgres, use my thing, and we need the variations, right? Because every developer needs some different extensions. I will have a large amount of images, which will mean I will have to configure the other pipelines to pick the right one. So this is actually this already. You could easily spend, also it is trivial on my machine to make it work in pipelines 1 week to make it correctly think about names, how you name the thing, because if you have 3 extensions, yeah, okay. Yeah, okay, then I got it, okay?
Actually, for me, the gist of this is that you switch from being a user of a container image to becoming a maintainer of
Yeah,
multiple container images. And
yeah.
that is a totally different role, right? With different responsibilities. And the question is, do we want our question was, do we want all of our users of Stackres, to suddenly switch from being container image users to being maintainers of container images? I don't think it's a good approach.
Yeah, but in my project, if I ask the question, they say, okay, maybe, but no one thinks about the implications, right? The implications is if one extension changes with the naive approach, what I mentioned here, we would have to run the first pipeline first, redeploy a new version, then call other pipelines which are affected, so in your communication mechanism, and rebuild, redeploy all affected software, for instance.
Yes.
And this will spend at least 1 week with that to test and whatever. Even if we get CI/CD code pipeline, code build, everything with CDK automated, still I would say 1 week until we get something with zero added business value.
Yep, exactly.
Yeah. And your approach is to pick the official image and modify it on the fly.
Well, not exactly, but not far from that. So basically, what we did, I was doing this research at the beginning, right?
Mm-hmm.
And so one of the things I like to do in life is challenge assumptions, not because of yes, but because I find a problem and I want to challenge it, right? And I need to find a solution. So one of the things that we have been told nonstop is that container images, they are like Merkle trees, right? They follow this approach where one layer depends on the previous one. They're all these hashes, blah blah blah.
Like Git.
Exactly. Mm-hmm. And that means they're unmodifiable. Like once built, that's it, right? So it's like, okay, let me learn about this, because in reality, when I was experiencing with Docker and layers and all that, and I looked at the internals, I didn't see where there was this chain. I was looking for a chain of hashes. And I was like, I don't see the chain. So let me look into it. And I started digging, and I realized that this chain of hashes exists, but only as part of the snapshotter. Like the snapshotter is, again, is the process that actually builds the container file system, the layers, right? But only for runtime, but not at the image creation stage. And I was like, okay, if at image creation stage there's no such a chain, and by the way, here I'm not container expert, so maybe the audience will point me that I'm wrong at some point, but so far what I'm saying works, so leads me to believe I'm not wrong. So if this chain of hashes do not exist at image generation time, so what is there? So the container image, if you really look at what a container image is no more. I mean, the container image is essentially a manifest. It's a JSON file.
Yeah.
Right. Could be several, more than one, because it could also have indexes and architecture indexes. But let's put it simple. It's a JSON file that points to tar files. It's a JSON file that describes some metadata about the image and then says, okay, this image is composed of 4 layers, and each layer is a tar file. And this is the shard, this is the digest for that tar file. So when you download an image, when you do a Docker pull, it will first pull this manifest, we'll read the manifest, we'll get the digest of the layers, and then we'll pull the layers. So actually, some of those layers, maybe they're already on your computer. And that's why you see that sometimes a layer is not re-downloaded because it's already present on your file system. And I was thinking, okay, if the manifest is the only thing that glues together these layers, I could take a base image of Postgres with 1 or more layers. And then if I would create container images for every extension as a single layer, it doesn't need to be, but to put it simple, one container image for a given extension, let's say timescale we're using for the sake of illustration here, right here. So we build a container image just with timescale 1 layer, and let's say discard its manifest. I just keep the layer itself, and then I take the Postgres-based image, let's say it has 4 layers, and then I add the 5th layer of timescale, Then that is an image with what I want, Postgres plus timescale. Now I just need to write a manifest that will assemble them together. This manifest is a JSON file. So can I do this dynamically? Could I do this in real time? Yeah, I can compose JSON documents on the fly. And this is what we did. So what we have written is a registry. So it's a registry, it's a software component that serves container images that takes building blocks, what we call building block images, which is either a Postgres-based image or images which just contain one extension. And based on a user preference that we can talk about how we do this, it can compose on the fly container images, Docker container images, technically OCI container images with exactly the extensions that you want and no more than that.
Mm-hmm.
So with these, we achieve all the goals that we wanted. We have minimal images because they don't have more extensions than those that you wanted. They contain the extensions that you wanted, which was obviously the main goal. And they're immutable because once the container image is served to you, it's fully undistinguishable from a container image that you have built generated by classical methods. And just to be clear, this is not calling Docker build behind the scenes. That would take seconds. This generates the images in milliseconds because it's only generating the manifests. Actually, there's more than one. It's at the very least, the minimal case is 2 manifests need to be generated dynamically based on the user preference. Like I want extension timescale, I want L3, and I want any other extension that you may want at the time, right? And so builds the manifest dynamically and serves you the image. And again, from a user perspective, they're indistinguishable by a handcrafted, slow build process with Docker build your own image. Is indistinguishable.
That's pretty cool. What I understood is the magic is in the registry. So, which is genius,
Yes.
because as you explained that as okay, what we could do, we could modify something on the client side. So if we read, it creates the manifest on the fly. But it is even better. It's in the registry. It means, for me, I will pull image from your registry, and the image will be constructed on the fly in milliseconds by manipulating the JSONs. The tars are immutable because they are always assigned and so forth, and you never touch that.
Exactly.
And what I get is a stable image name with and I think the registry has additional API, so I can say I would like this with this extension. So I get a little bit more data, and then I get custom built image downloaded on the fly, which is pretty cool. And I have actually very similar use case. So for years, I was really successful with application servers. JBoss, Glassfish, and the build times were stellar. And what I did is, this is exactly the approach like I'm talking 10, 15 years back. And what we did in our projects is the following with Docker. So I don't like dependencies. So I picked as much as possible from microprofile or Java or Jakarta. Means my wars were like 50K, 50 kilobyte, 100 kilobyte, 200 megs, 200 kilobyte, but not megs, because it's just business code. There were no libraries in the wars. So there's an old project on GitHub from me called Docklands, and what I did, I created just the images of application servers which were startable, and the last layer was the war. So what means the entire build of application servers was 1 second, 100 milliseconds. It's crazy fast because I just added the last layer and the server booted and the application went online. And back then, I remember all the other approaches were way slower because they had to build, the entire Docker image with all the dependencies. And I stopped doing this with Quarkus, but you could also do this with Quarkus, even with your approach, because if you look at the Quarkus build system inside Target, it also separates Quarkus from your business jars. So you could actually have your base image, and I will call it not Quarkus rather than my application. And then with your approach, you can just swap the application logic, which is kilobyte, and replace it on the fly. It could be interesting just to test that. The problem with Quarkus is so fast that it doesn't matter. But it's really interesting approach. So it means your product, let's call it your runtime or product, your project is the Docker registry. Yeah? You have a specific Docker registry, and then everything else remains like it is.
Let's give it a name. It has a name. It's called DOCER, which stands for Dynamic OCI Registry. Dozer.
Dynamic OCI Registry.
That is correct. So yes,
DOCER, I think. Yeah, those
Dozer.
DOSIR, right? The dynamic, because the D is from dynamic, O from OCI, and D OCIR.
It's OCI is as in OCI, right? The
Yeah,
standard
and R. So OCI
R,
prepended with D and with the ending R.
yeah.
And is it product? Can you buy it, or is it or?
It's going to be published as fully open source software.
Okay.
It's not public yet, but will be soon. That's our intention. We want to share this with the world because we see this as an approach.
Another idea before I forgot. So what you could do is because this is your registry, what you actually could do, implement hooks and say, notify me if there is something wrong with the layer issues, security issues, whatever. And you can send a signal and I can rebuild my pipeline will start and redeploy the software.
Okay.
Imagine AWS. So so this is what I'm working right now is the easiest. So I have a code build, code pipeline. And actually, the entire automation process with code build and code pipeline is usually triggered by event. This is a GitHub event with override and usually event bridge because I use the pipelines for releasing software and approvals and so forth. So we trigger the pipelines with event bridge event usually, or step functions. Step functions is easier. Functions is easier. So do step functions, and there is one step run code pipeline. So now I can run your OCI registry somewhere. If something changes, you send me an event bridge event. And I can redeploy the software because of security issue.
Yeah,
for me, nothing. You only need a small bridge between dozer, and a custom event. Basically, this is nothing. So if Java is like we're talking about a Lambda in worst case with 10 lines of code, or even on your part, you will have to emit event bridge event in Quarkus. This is nothing. This is
actually, you know what? I was going to tell you that there's an implicit way of doing this already built into Dozer. So basically, as part of Dozer, right, you need to write some business logic. Dozer, let me use a terrible example, but for the sake of completeness, I guess you remember the transition we had from the static web to the dynamic web with PHP, right? Or
one last question. Sorry to interrupt you. The Dozer could run as a Lambda, right?
Yes, it can do that. Yeah, absolutely. So, okay, spoiler here. Dozer is written in Java with Quarkus. It's just Quarkus. It's a Quarkus application.
Yeah, this is what I suspected because you have no time for anything else. So, yeah.
Yep. So it's, the OCI distribution spec, which is what actually technically implements and turns your software into an OCI registry, it's no more than an HTTP server with some APIs on top of it, right? So that's it. It's an HTTP API. Well, obviously, that's a lot of things behind the scenes. But to achieve this dynamicity, right, to be able to compose layers dynamically, we need to have some business logic. And this is akin to what I was saying, right? The transition from the static web to the dynamic web, where if you remember PHP, you could run some business logic and that will render the web page. Or
JSPs. I remember JSPs, Java server pages.
Yeah. Of course. I just mentioned PHP because that's how I started. Then moved fortunately to the Java world and did all the path, right? Starting from JSPs. But I really remember this transition with PHP. That's why I illustrated as an example. Anyway, it doesn't matter. So yes, you render the HTML dynamically. So here we also need some kind of business logic to generate the container dynamically. Because okay, so which extensions do you want? How do you express this as a preference? And so the way it works is that let's talk Java, right? Because audience here will understand this. So Dozer essentially exposes an interface. It's that simple. There is an interface which has a method that takes as input what we call the URL. Is technically the name and the reference of the image. So it's basically whatever is, if you do Docker pull, whatever, what sits on the right of it is the name is what comes before the colon. And if there's a colon, what comes after the colon is called the reference. So name colon reference is the input to the method of the interface. And the output is essentially an array of layers, an array of the digests of the layers you want to compose. And this is in Dozer an interface. So you need to provide, if you want to use Dozer, you need to provide an implementation to this interface. And so this interface, this method, what it does is basically map between the user preference, what you did at Docker pool time, and the set of layers you want to generate. And that's just all up to you. We have written an implementation of this interface for Postgres for our particular use case. Docker is fully agnostic. It's not tied to Postgres, not tied to anything. It's very generic. So in our case, what we did is craft a URL. We call it a URL, the name reference, because it looks like an URL. So basically, if you want to have Postgres and 3 extensions, you will say Docker pool or non-pool, whatever you want to use, right? Then you say our registry, wherever it's hosted, /Postgres. And then to separate the extensions, we do /e as in extensions, / and then every extension also separated by a slash. So for example, you could do Docker pool, registry URL, /Postgres, /e, /Citus, /L3, /pgstat statements, /pgstat kcache. Boom, and that's it. This will call the interface. The interface will resolve, obviously, to the implementation that we have. And then we'll have an implementation that, oh, you want to have Postgres with Citus. We'll look into some internal, we can talk about that, how it works. We'll look at some internal data, find the digests for the layers that have been built against that particular version of Postgres, because we build extensions against particular versions of Postgres. Find them, digest, and then return to Dozer and say, hey, Dozer, these are the layers I want to compose them. And then Dozer understands, based on those layers, how to generate the correct manifests and serve the image dynamically. And that's how it works.
But your implementation is just mapping of Postgres features to the actual images, right? So if you have to do it for Quarkus, whatever, it would be probably doesn't make sense to have Quarkus extension to be more my project. So I will push a jar or create an image for my project, and then it will automatically return always to base. Oh, this will be interesting, because if base Quarkus image changes, I will get a fresh Quarkus image with my project. So we could have patching for free, and we could, for instance, always build a container or only build the container on demand. Exactly. So it means what we could do is, we send the event bridge event to you. You decide what to build, and then we get back, the actual statement to the pipeline, and this would build the image, for instance. Or we can do it proactively. Yeah, we have to do it, because if there is no new release, we still have to build if there is some problem with the base operating system or Quarkus or Java or whatever, right? So, yeah, but this is actually pretty cool. And what I like about that, it is transparent to the outside world. So this is your still Docker, the same binary, and the only difference is a registry. What I hoped for, that you are actually manipulating, the image binary contents. It would be more complicated. And but this is actually this is absolute use in enterprise, right? As I mean, this could be a great product.
Yeah, thank you. And actually, this business logic is where you can put your own event to event bridge, for example, if you need.
Yeah, absolute event bridge client. So I was just thinking, because right now I'm completely serverless. I need a project with some Docker or whatever. But the separation, this is as Quarkus came out, I just wanted to have the separation, what you actually implement. I said, okay, why not to have, because mostly I use Quarkus as microprofile. And the way all the microprofile extensions, I knew what we need for a typical microservice. So the idea was to have a base Docker image with that. It will never change. And you only provide your Java code. This was the idea, right?
Yeah. And actually, for example, you can also use this now for AI container images, because maybe you want to have LangChain for J, for example, but then you may want to use different models or different APIs, and those could be built as layers, right? And then you can generate a dynamic container image with only the bits of code that you really want to. There's plenty of use cases where you may want to use dynamic container generation. In fact, what I found is that if you look at many container images on Docker Hub, there's a lot of variations. Oh, this image with Alpine, this based on Debian, this with these modules, this with not. And I've seen some providers actually talking about cardinality and creating like a lot of explosion of different images variation, just because they cannot build them dynamically. Well, now they can.
Nice. It's actually great and solves, of course, problem for you for Postgres, but also, in my world as a Java, Quarkus, and project world, also interesting thing. And So what we did with standard is we use ECS Fargate for testing of some servers in the past. And what I did, if you push something to ECR, you can subscribe as event listener, and this trigger the pipeline. So this would be very similar to your case. So you will be before, but the cool story is could be serverless. That's the great thing, because I immediately thought, where to run it, your stuff, but it could be Lambda. Then it really does matter. Yeah.
There's actually not similar in regards to running to dynamically composing images, but there is an OCI registry built by Cloudflare that is serverless. It runs as a Cloudflare worker, if I'm not mistaken. And because yes, you can run registry serverless if you have your storage for all the digest of all the layers on something like S3 or R2 in their case, it can run serverless, so it can run as a Lambda.
But this means, high availability. Otherwise, if it is not serverless, this is, the beginning of the end. The load balancer VPCs, because it fails, you cannot build. So this on serverless, no problem, right? Because the Lambda will start and stop. And of course, low cost, of course, but the high availability we get for free.
Yeah. So just to give you a little bit more detail here, how this business logic works, because we're talking about mapping from this user URL to the set of layers, right? For this operation, typically you need to look into some metadata. For example, if I'm saying Postgres/Citus, I need to know which Postgres version I'm serving, and I need to find the particular version of this extension compiled against this particular version of Postgres, right? And so on and so forth. And then when I look at by name, because Citus is a name, but I want to look for the digest, I need to provide to Dozer the digest on my business logic, right? So Dozer also has a built-in mechanism that when you do a Docker push of a image, which in our case is kind of a layer, a brick, right, a building block, could be Postgres or an extension, it automatically captures all the metadata from this image, the automatic metadata plus all the labels that you may have put it, and stores that into a surprise Postgres database, and then exposes this Postgres database to your business logic if you want to check it. If you don't want to, like, you can do anything you want, but you can consult this database so that you can find the digest of the layers that you particularly want. And this is what our business logic does. So we have written Dozer, fully Postgres independent OCI registry, which has the ability to compose dynamic images, and then our particular implementation for Postgres, which solves our use.
Yeah, for you, Postgres makes sense because it's Postgres anyway. For me, it would be S3 or DynamoDB, for instance, because we don't have to run Postgres to have the registry.
And actually, the metadata capturing process is also behind an interface. So yeah, if you want to write the data to DynamoDB, you just need to implement that interface yourself and right there.
This could be even interesting for the job runner from Ronald from last podcast, the Dozer, because he runs, I asked him, the most workloads are container workloads. And the job definition, if swaps the job definition could be also interesting. Pretty cool. I think the first time in our history, we completed our agenda, something, right? So we completely discussed something what we actually planned for a year.
I would say so. Yeah, it took us a long time, but I think we have done it.
Yeah, usually it was complete chaos. And the first time we actually discussed something from the beginning to the end. And of course, I have to invite you back because, this Tigris and Quarkus is still undiscussed. So we touched this several times, but we don't really discuss what you did. And it was a nice conversation. And where people can buy, or if they want Dozer, where can they find you? And by the way, your blog is stellar. eht.es, right?
Yeah.
I look at this. It is beautiful. This is your artist. This is incredible. So everything is. This looks really nice and fully professional. It's like, oh my god, this looks. You look like a professional actor within the blog. This is too good. You have to do something. It looks like almost like a CEO blog, but not as a programmer blog. So.
well, if you scroll down the content, right? So I'm putting there up all the talks that I've given at conferences. There's, I think, more than 140 as of now.
So. Yeah, a map. Yeah, I saw a map, a beautiful map. But upcoming is 0. This is a bug.
Yeah, to be honest, I'm a little bit lagging behind the update mechanism. And so the map, I'm actually thinking whether I should change this because the map came from the time where we were traveling and I want to see people where I'm going to be next.
Yeah.
But now many things are virtual, and it's like, okay, where do I put the pin on the map?
Yes, yeah, exactly.
And anyway, if I'm doing something virtual, people will not be able to meet me in person. And so it's going to go through some rework, this webpage. But yeah, the main point is to have all my talks, podcasts, blog posts referenced from there. And yeah, there's a lot of content out there.
Perfect. So eht.es, what's the name of your companies and where people can find those are? DOCIR. Where to find it?
Yeah, so my company name is Ongres, ONGRES, which means is the short for on Postgres, website ongres.com. Stackgres software, fully open source software for running Postgres on Kubernetes. Stackgres.io, it's a stack of components you need on top of Postgres. And Dozer doesn't have a website yet. It's going to be made public probably towards the end of this year, 2025. I don't know exactly where it's going to be, but if you follow us on Twitter and social media, whatever, we'll be definitely announcing it. But it's going to be fully open source for anyone to inspect, to use it, and hopefully to collaborate and help us make it even better.
And your company also delivers Postgres trainings, right?
Oh, we do everything Postgres. Trainings, 24/7 support, Oracle to Postgres migrations, Postgres on Kubernetes, and all the products that we are building now behind.
And your client seems to be satisfied because the last time we met, someone came to us and say, "Thank you so much that you confirmed that you will deliver the workshop deep dive." And I told him, never ask about deep dive because you will end up, discussing the assembly, then the C Postgres, and then maybe so this was actually a nice experience. So if you would like to have a Postgres training, you can also contact Ongres, right?
With pleasure, absolutely. Yeah. All Postgres.
All Postgres and a bit Quarkus and Java as well. Right?
Oh, there's plenty of Java in our company. Stackgres is built in Java. It's over 250,000 lines of code.
Yeah, perfect. So this is why I'm talking here. But Postgres is also interesting. So I use Postgres all the time. So thank you a lot and see you next time.
Thank you, Adam, very much for having me.